objective is design of helical gear using MATLAB or Octave. ठीक है, तो 11 से कॉलेज खोल रहे हैं, तो यू कैन वर्क ऑन MATLAB also, no problem. So let me share the question first. So before starting the question, let me give some idea. For example, in case of helical gear, there are two modules. One is transverse, one is normal. So we will take normal module in the calculations. So normal module will be taken in the calculation. Mn. Mn is the normal module. Okay. Then the beam strength formula will be Mn B sigma B y. This will be our beam strength formula. A slight change is there, only Mn we are using, normal module, and everything is same. And this y is Lewis form factor. So in the helical gear, this y will be used for virtual number of teeth. This y will be used for virtual number of teeth. ठीक है? अब virtual number of teeth के लिए क्या यूज करते हैं? है ना? Because helical gears calculations are very complex, है ना? Due to the inclination of the teeth. है ना? In that case, when we see it from normal direction, है ना? Then it is considered as a virtual spur gear. Helical gear is considered as a virtual spur gear. So, what are the number of the teeth on that virtual spur gear? So, there is a formula that we will derive in the theory class. We will derive करेंगे उसको. But अभी हम सिर्फ use करेंगे. ZV is given by Z divided by cos cube psi. ZV, V is virtual, है ना? Z means number of teeth. So number of the teeth on the virtual spur gear, है ना? Helical gear is considered as a virtual spur gear for the calculation purpose. So this virtual number of teeth is given by actual number of teeth divided by cos cube psi. Here this psi is the helix angle. Psi is the helix angle. Okay? So we will use this formula, we will use this formula, then the design of the helical gear can be understood. So note down these formulas. और अब मैं
बलराम लिंक दियो.
Now I am sharing a file. Let me open that file first.
Good afternoon, sir.
Good afternoon. Good afternoon.
Good afternoon, sir.
Good afternoon. Good afternoon.
कैसे हो सर?
हाँ, बस म्यूट कर लें अपने आप को, है ना? आई एम फाइन. जैसे ही स्क्रीन पे फाइल विजुअल हो तो मुझे बताइएगा. Yes, is the file visible? And I have shared VV Bhandari textbook.
Yes, sir.
Okay. So I'm just moving to helical gear design. So I will take a problem on helical gear. So helical gear starts from here. Yes. So I will take the module question. Yes. Is the question visible on the screen? A pair of helical gears consists of 24 teeth pinion. So parallel helical gears, parallel helical gears consist of 24 teeth pinion. So how many teeth on the pinion? Let me note down the given data first. So pinion, let I am representing by Z1 or ZP. So ZP is 24. So these are the actual number of teeth on the pinion, right? So what is the virtual number of teeth? The virtual number of teeth is given by ZP divided by cos cube psi. Okay? And these teeth will be useful in finding the Lewis form factor. Correct? We will mainly discuss the differences. What are the differences in the design of spur gear and what are the differences in helical gear? So changes we will discuss. In spur gear, there is no concept of virtual. There is no concept of virtual, but in helical gear, there is a concept of virtual spur gear. So let me read the question. Rotating at 5000 RPM, supplying 2.5 kilowatt power. So kilowatt is 2.5, RPM is 2000. 2000 RPM is 5000. It is given 5000 RPM. Then the speed reduction is 4:1. So speed reduction means it is a gear ratio. ठीक है? स्पीड रिडक्शन को गियर रेशियो क्यों बोल देते हैं? देखो, द स्पीड का मतलब होता है स्पीड ऑफ द पिनियन डिवाइडेड बाय स्पीड ऑफ द गियर, np by ng, speed of pinion divided by speed of pinion. Basically this is the speed reduction. Pinion rotates faster, pinion is a smaller gear, so it rotates faster than gear. So np is higher than ng. Correct? Always np is higher than ng. So this ratio is the speed reduction, np by ng. But by formula, np by ng is equal to zp divided by z. That we have proved. In 3-4 class before we have proved. So this zp by zp is known as gear ratio. zp by zp is the gear ratio and np by ng is the speed reduction, but they both are equal. Their numerical value is equal. So in question it is mentioned speed reduction is 4, means gear ratio is also 4. So that's why I am writing I equal to 4. But I is not the speed reduction. I is the gear ratio. Okay. So go further. The normal pressure angle and the helix angle are 20 degree and 23 degree. Normal pressure angle and helix angle. So let normal pressure angle is alpha n and helix angle is psi. Pressure angle is 20 degree and psi is 23. Okay. So alpha n is the normal pressure angle. For the calculation purpose, alpha n will be used. And there are again two pressure angles. One is transverse pressure angle and one is normal pressure angle. So alpha n is 20 degree. And this is 23. Again, there are three profiles. One is 20 degree, one is 14.5 degree, and one is for 20 degree stub tooth. So 20 degree is the by default profile. It is given in question. So psi is 23 degree. When psi is 23, you can find the virtual number of teeth from here. So it is 24 divided by cos cube psi. Psi is 20 degree. Solve it. 23, yes. Psi is 20. Solve it. How much it is coming? The service factor and the factor of safety. Service factor is CS, factor of safety is FS, and these are 1.5 and 2 respectively. So it is 1.5 and 2. The gears are finished to meet the accuracy of grade 4. Anybody has got the answer for the virtual number of teeth? Online students, Deven Pratap, tell me the answer for ZV, virtual number of teeth. You are not doing the calculations. Are you having the calculators? Always put calculator with you during the theory class and lab class both. So let me solve 24 divided by bracket cos 23 bracket close power 3.
30.77.
30.77. Correct. So it is 30.77 teeth. These are the teeth. 30.77. Now, come to the question again. The gears are finished to meet the accuracy of grade 4. Grade 1, grade 2, grade 3, there are 12 grades in the gear finishing. So grade 1 means it is very fine finishing. Grade 2 below that, grade 3 below that, grade 4 below that. There are different requirements. So if gear is made of grade 1, it means the error between the gear profiles will be very less. Error between the gear profiles means pinion profile and teeth profile. During manufacturing, errors can be minimized, but they cannot be eliminated totally. Errors cannot be eliminated totally. There are certain errors. So in grade 1 gear, the errors will be very, very less. In grade 12, the errors will be high, somewhat high. So here the grade 4 is given. बस इतना समझ लीजिए कि grade 4 उसकी finishing को represent कर रहा है. Now first part is, in the initial stage of the gear design, assume that the velocity factor accounts for the dynamic load. In spur gear, we are also taking this velocity factor CV. CV. How many formulas for CV? 3 by 3 plus V, 6 by 6 plus V, 5.6 divided by 5.6 plus root V. So in helical gear, again you will refer the data book. You will find the formula from there. So in helical gear, the formula for the CV is 5.6 divided by 5.6 plus root V. I think this is the formula. You can take it from data book. No need to remember it. So let's finish the question. Assuming the pitch line velocity to be 10 meters per second, estimate the normal module. So pitch line velocity is given how much? Pitch line velocity is given 10 meters per second. And we have to estimate the module. I have to estimate the module. So once the module is known, everything can be found. Addendum of the gear, dedendum of the gear, clearance of the gear, tooth width of the gear, tooth space, everything can be found. So module is the important parameter. So we will take this question up to module only. Rest of the part can be solved by yourself. So design means we have to find the module. Module is important. So this is the question. This is the given data. Already we know the design of spur gear. The similar steps will be there. So what is the first step in the gear design? The first step is to find the weaker. Can you tell me who is weaker here? Gear is weaker or pinion is weaker? देखो क्वेश्चन को ध्यान से देखिए, मटेरियल पे ध्यान दीजिए. बोथ गियर्स आर मेड ऑफ, see this line, both gears are made of hardened steel, SUT 750. So both gears are made of hardened steel. Both gears are made of same material. So when they are made of same material, Which is always weaker?
Pinion.
Pinion is always weaker. तो ये तो clear हो गया. Pinion is weaker in this case, in this question, in this problem. है ना? So pinion is weaker, है na? Because they both are made of same material, and SUT of the material is given. Hardened steel material is given 750 Newton per mm square, 750 megapascal. So pinion is weaker. Pinion is weaker because they are made of same material. है ना? ये पूरा लिखना है आपको. You have to write because both are made of same material. That's why pinion is weaker. है ना? Underline कर दीजिए आप उसको. कभी भी एग्जाम्स में you are solving the question, write this language and underline it. है ना? Bold letters. So in MATLAB program also you print this line. है ना? ये print करना है आपको. तो हम step 1 में MATLAB program में इसे we will print because both are made of same material. Pinion is weaker. चलिए next. When the pinion is weaker, we will apply bending logic. है ना? Bending. Gears fail in two things. One is bending and one is pitting phenomena. है ना? There is one bending phenomena and one is pitting phenomena. So in this question, we will consider which phenomena? Pitting or bending. है ना? Generally we consider both, but in this question, data according to given data, we will go for the beam strength first. So for the safe design, what is the logic? Beam strength must be greater than P effective, SB equal to factor of safety into P effective, and in place of SB, I will write Mn B sigma B Y. Mn means normal module, B is the phase width, sigma B bending stress, Y is the Lewis factor for the virtual number of teeth, not for actual. You have to find Y for the virtual number of teeth, and virtual number of teeth are 30.77. So go to the data book, find the Lewis factor for 30.77. चलिए जाइए अब बताइए क्या वैल्यू आई. मैं भी वो टेबल खोल लेता हूं. ठीक है, अपनी अपनी डाटा बुक में प्लीज ओपन द टेबल फॉर द वर्चुअल नंबर ऑफ टीथ. वही टेबल खुलेगी जो अभी आप स्पर गियर के लिए चेक करते थे ना. द सेम टेबल विल बी हेल्पफुल. सो ओपन दैट टेबल. हैव यू फाउंड द टेबल? यस, यस. Is the table visible to you, all of you? Online students, table is visible. Z equal to 15. It is 0.289. It is visible. Like Nikhil Agrawal, it is visible table on the online mode.
Yes, sir, visible.
Okay. So in this table, go to 30.77. Go to 30.77. So 24, 5, 6, 7, 8, 9, 30, 32. So there is a Lewis factor for 30 and there is a Lewis factor for 32. 30.77 is not mentioned in the table. So what will we do? We will take the help of interpolation. So for 30 teeth, the value of the Lewis factor is given 0.358. For 32, the value is given 0.364. 0.364, and we want the value for 30.77. It is question mark. It is not mentioned in the table. So if it is not mentioned in the table, then we will take the help of interpolation and a linear interpolation. So as per the linear interpolation, the value of Y will be given by, how it will calculate? The first value, देखो मैं I am giving you the logic. This is the first line, this is the last line, this is the middle line. ऐसे समझ ले. F M L. F is first line, M is middle, and L is last. या first, second, third जैसे भी आप you can use it. So this is given by first value F plus last minus first. तो पहले फॉर्मूला लिखो, last minus first divided by last minus first into middle minus first. ये इंटरपोलेशन से ये फॉर्मूला निकल के आता है ना, यूनिटरी मेथड का हो या इंटरपोलेशन का हो, व्हाटएवर, दिस फॉर्मूला निकल के आता है. तो इन दिस फॉर्मूला फर्स्ट मींस 0.358, लास्ट मींस 0.364, है ना, फर्स्ट लास्ट, एंड क्वेश्चन मार्क इज मिडिल फॉर दिस लाइन, एंड हियर फर्स्ट इज 30, लास्ट इज 32, 30.77 इज मिडिल ओवर हियर. ठीक है, सो आई विल यूज 0.358 plus last minus first 0.364 minus 0.358 divided by last minus first हो गया, then last minus first again 32 minus 30, then middle minus first 30.77 minus. इसको अपने मतलब माइंड में थोड़ा फिट करिए. इंटरपोलेशन ऐसे ही करते हैं ना, और ये है कुछ नहीं, मतलब जस्ट एक यूनिटरी मेथड है. जैसे इस तरह से कोई ग्राफ आ रहा है ना, तो इसको मतलब आप ऐसे समझ सकते हो. जैसे देयर आर टू एक्सिस है ना, वन एक्सिस इज लेट दिस इज द नंबर ऑफ टीथ है ना, सो इधर तो वी आर टेकिंग द टीथ Z. Z is the number of teeth on a one axis. On another axis, I am taking the Y. So as the teeth are increasing, the Lewis factor also increasing. Teeth are increasing, Lewis factor is also increasing. So you will get a straight line. The linear line between them. So let this is a linear line. This is a linear line. So this is the first point. For this first point, the teeth are 30 and the Lewis factor is 0.358. So the coordinate of this point is, this is 30 and this is 0.358. And for the second point, teeth are 32, this is 0.364. This is 32, this is 0.364. Okay. And this is the point on the line somewhere. 30.77 will lie on this line. So let this is your 30.77. Then you have to find the value for this. इस तरह का कुछ आपने एसएन डायग्राम में भी तो करा था. इन एसएन डायग्राम में आप ट्रायंगल सिमिलरिटी लगाते थे ना. So same triangle similarity you can use here, है ना. You can use a triangular similarity. And by that triangular similarity you will find this formula. ये फॉर्मूला वहीं से डिराइव होके आएगा. तो मैं तो इसको ऐसे ही याद कर लेता हूं, आप भी ऐसे कर सकते हैं, है ना. फर्स्ट प्लस लास्ट माइनस फर्स्ट डिवाइडेड बाय लास्ट माइनस फर्स्ट मल्टीप्लाइड बाय मिडिल माइनस फर्स्ट. फटाफट आ जाएगा, है ना. चाहे ट्रायंगल से कर लो, जैसे भी चाहो. आई थिंक इट इज क्लियर हाउ टू डू द इंटरपोलेशन. If the teeth are not given in the table, use the interpolation. So what is this value coming over here? Please calculate it. What is the value of Y? Yes. Y की वैल्यू बताएं. What is the value of Y? 0.36. ठीक है. और 3 डिजिट तक यूज करें. Use up to 3 digits for the accuracy. How much it is? 0.364. चलिए. So it is 0.364. So Lewis factor part is now over. So let me put the values. Mn is the unknown. B is the phase width. Is the phase width given to you? It is not given. So you will take the assumption. So what is the assumption? Right assumption for the phase width? Phase width can be kept between 8 times module to 12 times module. B equal to 8 times module to 12 times module. And it is the normal module, so I will use Mn. It is Mn. I think in spur gear also we have discussed this thing. The assumption for the phase width is 8 times module to 10 times module. So what is the value you will take? What value you will take? बताइए. Anyone? Which assumption? कितना लेंगे आप? 8m से 12m के बीच में कुछ भी ले लीजिए. 8m 12m के बीच में 10m ले लेते हैं. 10mm is the right assumption. So I will use in place of B, it is 10 times mm. Sigma B is given by SUT divided by 3. SUT divided by 3. So it is 750 divided by 3. Y you have already calculated how much? 0.364. So it is 0.364 equal to factor of safety. What is the value of factor of safety? It is 2. Then PT is the tangential force. PT is the tangential force. How will you find PT? PT is found by 2 times mt divided by diameter. 2 times torque divided by diameter. PT. So let me find PT first. Please note down this. Take a screenshot. I will rub it. PT is given by 2 mt divided by d. I will calculate. First, note down this. So can I rub it? Let check. PT 2 times torque divided by diameter. 2 times torque divided by diameter. So you will find the tangential force for pinion or gear. बताइए. Who is weaker? Pinion is weaker. So we will find the force on pinion. Okay? And you already know that the force on the pinion and the force on the gear is always same in magnitude but opposite in direction. So you can find this value for any gear. The answer will be same. Answer will be same. But in our case, torque is given on pinion or torque is given on gear? Read the question. Torque is given on pinion or torque is given on gear? So read the question. Read the question. It is given for the pinion. So power is 2.5 and RPM is 5,000. This RPM is the RPM of pinion. So by this data, we can find the torque on the pinion. Okay. So let's first find the torque. So torque is given by 60 10 to the power 6 into power is 2.5 divided by 2 pi into 5,000. Solve it. Yes, Aditi, value बताते रहिए फटाफट.
Yes, sir, कर रही हूँ.
यस कृष्णा चौहान बताइए, कोई भी बताइए। फोर सेवन सेवन फोर 0.6482 तो 65 मान लेते हैं, है ना। तो इट इज न्यूटन एमएम 4774.65 न्यूटन एमएम। ओके, यूज दिस टॉर्क हियर, so it is 4774.65 divided by diameter. So you will take the diameter of pinion or diameter of gear? You will take the diameter of pinion because you are using torque on pinion. So you will take the diameter of pinion. So let's write dp over here. dp, diameter of pinion. So now what is the diameter of the pinion? Is it given in question? It is not given in question. It is not given, but you already know that dp is given by m times zp. dp is given by m times zp, d equal to mz. So I can replace this dp by m times zp. So this is 2 times 4774.65 divided by m. M is transverse module. M is transverse module. And if we will use dp in terms of transverse module, then there is two unknowns. One is normal module and one is transverse module. So let's convert this module into normal module so that there will be only one unknown. Okay? So what is the relation between the normal module and the transverse module? I have told you in the last class, if you remember, when we are playing the quiz, I have given you the formula relationship between the normal module and the transverse module. So what is that relation? Anybody remember? What is that relationship? So that relationship is mn equal to n cos psi. Mn equal to m cos psi. I have told this formula. I have given this formula at the end of the quiz in the previous lecture. We will prove it in the next theory class how this comes. So mn equal to m cos psi. M is transverse module, mn is normal module. So this m can be replaced by m equal to mn divided by cos psi, and psi is 23 in our question. So this m can be replaced by mn by cos 23. So it is mn cos 23 and zp. What is the value of zp? What is the value of zp? 24. So it is 20. Solve it. The denominator part is mn and other parts are numeric values. So how much it is coming? बोलिए. Solve कर दीजिए. Let me solve. 2 multiplied by 4774.65 multiplied by cos of 23 equal to divided by 24. So it is coming 366.25. 366.257. I can say it is 26. 366.26 divided by. So this is my PT. So I can use this in place of PT in the main formula. So let me use 366.26 divided by mn in place of PT. Then service factor. What is the value of service factor in our question? Service factor. It is given in question. Factor of safety. No, that is service factor. So I will use 1.5 in place of CS. Factor of safety is 2 and service factor is 1.5. So in place of service factor 1.5, in place of factor of safety 2. And in place of PT 366.26 divided by 10. Correct? Now, velocity factor. Velocity factor. So what is the formula for the velocity factor for pitch line velocity 10 meters per second? So the formula is 5.6 CV. Let me write the formula is 5.6 divided by 5.6 plus root of P. So it is 5.6 divided by 5.6 plus root of 10 because velocity is given 10 meters per second. So please solve it. What is the value for velocity factor coming over here? Yes. Find the value of 0.639. Good. So it is 0.639. This is the velocity factor. So in place of velocity factor, I am using 0.639. So this is the main equation. This is the main design equation. This is the safe design equation. Start from here. Calculate everything. Calculate bending stress. Calculate. Assume the phase width. Take the Lewis factor for the virtual number of teeth. Virtual number of teeth. Find PT. By this logic, first find the torque, then find PT. In terms of normal module. In terms of not transverse module, convert the transverse module into normal module. Then use. So in this equation, only the unknown is normal module. Only the unknown is normal module. Find normal. कितना आ रहा है जरा बताइए. सॉल्व करें सभी लोग. So can I rub it? This part? Have you noted? Yes. Yes. Now tell me what is the value for the normal module? Yes, anyone from online students? किसी का भी आंसर आया तो बताइए. 2 into 366.
1.23.
1.23.
1.236.
236. So we can take 1.24. 1.236. Let it is 1.24 mm. So this is the normal module. Now what is the transverse module? Mn divided by cos of psi. So it is 1.24. Let after finding the normal module, selection of module is the next step. Selection of module. So how will you select the module? There is a table in the data book for the series of module. So go to the data book and find the next value more than 1.24 in the data book. So what is the next value in that table? Go to the selection of module in the chapter of helical gear. So there is a table for the selection of module. In that table, see what is the higher value more than 1.24. So that is your final module. So have you find the table? Mr. Devendra Pratap, are you listening me? Let me see how many participants are with me. Let me check. Kunal Parashar is with me, Ajit, Devendra, Hariom, Chitesh, Balram Agrawal, Apar Pandey, Hari Krishna Yogiraj, Mridul Agrawal, Prateek, Deepak, Laksh, Aman, Divyansu Giri, and Utkarsh Kaur. So many students. Okay. So, have you found the table in the data book? Not able to find. In Helical, if there is no table in Helical, go to the table in the spur gear. So in that table, what is the next value for the module? Because this helical gear is working as a virtual spur gear. So what is the next value for the module? More than 1.24. Choice one. Go for the choice one first.
1.25.
What is the next value? More than 1.25?
1.5.
1.5. So go for 1.5. So it is rounded off to 1.5 mm from the data book. Okay. So final logged module is 1.5. Final module is 1.5, not 1.24, 1.5. So when I will calculate transverse module, I will take 1.5 divided by cos of 23. Solve it. There are two choices. Always you go for the choice one. When we will go for choice two? This is the question. When we will use choice two? Correct? Sometimes preferred, please. Choice one is preferred. Always, this is the my first choice. If this is not available to me, then this is my second choice. So when we will go for the second choice? When there are some problem in the space limitation in the design of the gear has to be fitted somewhere. So if we will take the higher module, choice one module, sometimes there are problems in the space design, space limitation, due to space limitation. Then we can go for choice two. But initially you select choice one. So as per choice one, the answer is 1.5 mm. Now what is transverse module? 1.63 mm. Okay. Okay. So module part is over. Module part is over. Okay. Now, what are the dimensions of the gear? Dimension of gears. What are the important dimensions? Face width is important, yes. And pitch circle diameter of the pinion is important. Pitch circle diameter of the gear is also important. So we will calculate only three. Other addendum, redundum, that we will not worry because they are in the proportion of the module. So let's find the pitch circle diameter of the pinion. So dp is given by mzp. What is m? 1.63. What is zp? 24. Solve it. Solve it. How much it is coming?
$39.12.
39.12 mm. Now, similar fashion, calculate dg is mzg. 1.63. What is ZG? ZG given in question. ZG given in question. Number of the teeth on the gear. But the gear ratio is given. And what is the gear ratio? 4. So if the teeth on the pinion is 24, then the teeth on the gear will be 24 into 4. 4 is the gear ratio. So 96. So I can take 96 for ZG. Okay, ZG is I times ZP. I will remember ZG is I times ZP. I is the gear ratio. Correct? So it is 1.63 and it is 96. Solve it. Easy. How much it is coming? 156.48 mm. So DP is over, DC is over. The third important dimension is face width. So how will you calculate the face width? You can find the face width B equal to 10 times normal module. So it is 10 times, what is the value of normal module? No, that is the transverse module. 1.63 is the transverse module.
1.5.
1.5, yes. That is the 1.5. So it is 69. Okay. So this question is solved. Right? This problem is now understandable. What we have done, we have designed the helical gear in which we have found the normal module and transverse module. Right? In the formula of beam strength, normal module has to be taken care. And there is a relationship between normal and transverse module. So one is known, then other is also known. After finding the module, you have to go for the dimension of the gears. Other steps are similar. You can check the design in the similar fashion. Other steps are similar. Main thing is to find the module. For module, we have used the safe design equation, in which left hand side is the beam strength and right hand side is the effective load coming on the gear. For the effective load, PT is transverse force, and that transverse force can be found by logic. First find the torque, MT, then find 2 MT by D, and similar fashion. So this completes the helical gear design. Okay, from my side. Now you have to make the octave program for this total thing. Run the program, make the program, take all these steps. First find the maker. Second step, find the normal module. Third step, find the dimensions of the gears. And last step, print the results. So can you can make the MATLAB program or octave program and send me your code and output. Okay, so this is all for the today's class from my side. So if you have any query, please ask. कहीं पर भी कोई चीज आपको चुभ रही हो, है ना, कुछ समझ में नहीं आ रहा हो, है ना, इसमें काफी सारी चीजें की हमने इंटरपोलेशन को भी समझा है. We have also understood the interpolation part of Lewis factor, है ना, linear interpolation. तो क्या फॉर्मूला है? फर्स्ट प्लस लास्ट माइनस फर्स्ट डिवाइडेड बाय लास्ट माइनस फर्स्ट इनटू मिडिल माइनस फर्स्ट. याद भी हो गया आपको, है ना? जस्ट रिमेंबर, इट विल हेल्प यू. कभी भी आपको कोई चीज बीच की निकालनी है, यूज दिस फॉर्मूला. Not only in gear, anywhere else, if there is a linear interpolation, you can use this. Okay. So, can I end the class now?
Yes, sir.
Okay. Thank you. Thanks for listening. Thanks for watching.